Hello friends, today we will discuss the formulation of viscous force, that is Newton's law of viscous force. We know the derivation Fv समान Fv equals to minus eta A dV by dx, dV dx. This relation today we will prove. So for the calculation, first we will consider that layer Z0 plus 2 by 3 lambda, layer Z0 minus 2 by 3 lambda. We will consider a layer of area A along xy plane at Z0 in a gas under steady state motion. We know that flux, that is transport of physical quantity flux, it is defined as the amount of physical quantity transported per unit time per unit area perpendicular to the direction of flow. So flux J is equal to 1 by alpha C average N dash Q, where alpha is approximately 1 by 4 C average N dash Q, where C average is the average velocity of the gas molecules. N dash number density is number of molecules per unit volume, and Q is the amount of physical quantity transported. Here we will consider the amount of physical quantity transported Q, that is momentum. So the momentum transported from the layer at Z0 minus 2 by 3 lambda to Z0 plus 2 by 3 lambda. So the net momentum transported Q equals to, if m is the mass of the molecule, so the net momentum transported mvx minus from this layer to this layer minus mvx plus. This is the change in momentum. So J will be equal to 1 by 4 C average N dash. In place of Q we will write m Vx minus m Vx plus. So the flux J, this will be equal to the change in momentum through the layer. If we consider the change in momentum of the layer A, of the layer of area A, then the change in momentum we can write dpx by dt, that is change in momentum, that will be equal to 1 by 4 C average N dash A m Vx minus m Vx plus. Here A, there is the momentum transported through the layer of area A. So dpx by dt will be equal to this. Now here we can write, or we can rearrange the equation like this: 1 by 4 C average N dash A m Vx minus Vx plus. So Vx minus Vx plus, we can write this dV. So 1 by 4 C average N dash A m dVx. Now another dVx, we can write this dVx dz. Now dz, this will be equal to dVx dz, this will be equal to z0 minus 2 by 3 lambda to z0 plus 2 by 3 lambda. So dz we can write z0 minus 2 by 3 lambda minus or z0 minus 2 by 3 lambda from this layer to this layer. So here minus negative sign. Now we can write dvx by dz, z0 will be cancelled out, minus 4 by 3 lambda. Again dz I am writing dz this will be equal to z0 minus 2 by 3 lambda minus z0 plus 2 by 3 lambda dz. So here z0 minus 2 by 3 lambda minus z0 minus 2 by 3 lambda. So z0 cancel out, so minus 4 by 3 lambda. So I am writing here dz that is equal to minus 4 by 3 lambda. So the equation dvx, in place of dvx we write, so dvx that is equal to dvx by dz minus 4 by 3 lambda. Okay, so I am writing here 1 by 4 C average index a m dvx dz minus 4 by 3 lambda. So here again now we write that dpx by dpx dt that is equal to 1 4 will be cancelled out, minus a negative sign 1 by 3 C average n dash a m lambda dvx dz. Okay, now we know that eta that is equal to 1, or we can write n dash m. In this m we can write the mass of the gas per unit volume, so we can write in place of n dash m that is rho, so minus 1 by 3 C average n dash m rho lambda a dvx by dz. Now this is this 1 by 3 rho C average lambda, this is equal to eta viscosity coefficient minus eta a dvx dz. So dpx dt that is equal to minus eta a dvx dz. So dpx dt that is fv, so fv equal to minus eta a dvx dz. This is the Newton's law of viscous force. Fv that is equals to minus eta a dvx by dz, and here eta is equal to minus 1/3 rho C average lambda. So rho that is eta that is equals to eta equals to that is 1/3 rho C average lambda. Here negative sign. So eta equals to 1/3 rho C average lambda. This is the formulation of viscosity coefficient eta, and this is the formulation of the viscous force, that is Newton's law of viscous force. Okay, so if you like my video, please like the video and subscribe my channel, and if you want to know more about this, you can comment. Thank you.